Thank you for joining us tonight. I'm Megan Doherty, the director of the Museum of the White Mountains. As we gather today, we are all on Indigenous lands. Those of us at the Museum of the White Mountains are on Indakina, which is the ancestral and present homelands of the Abenaki and Wabanaki peoples. We're grateful for their stewardship of these lands and waterways. For those of you on Zoom, we've put some links in the chat where you can learn more about the Indigenous histories of your place at native-land.ca, as well as the Abenaki peoples of Northern New England through the Musée des Abenaki in Quebec. This year, our Mountain Voices series will explore winter in the White Mountains. This series is tied to our winter exhibition, Silent Shifts, Evolving Winters in the White Mountains, which will open on January 21st. It seems only fitting that we're kicking off our series today, as I had the first frost of the season at my house this morning, and the frost on Cannon was glittering above the vibrant foliage in the valley. The lateness of this first frost is also relevant to tonight's talk, Winter in a Warming World, with Elizabeth Burakowski. Dr. Burakowski is a research faculty member in the Institute for the Study of Earth, Oceans, and Space, and affiliate faculty in the Department of Earth Sciences at the University of New Hampshire. Please join me and welcome Liz.
Well, thank you for coming out to see me. This is a talk on winter in a warming world. This is the focus of my research, and the image I've taken here, this is from the Backcountry Ski Fest last winter in in February of 2004. And this, you can't tell by looking at it, was an exceptionally warm day. It was about 45, 50 degrees. We were skiing on essentially spring corn in the middle of February, and everyone was remarking about how out of season this sort of day felt in Northeast. My roots with skiing go way back. This is actually prior to learning to ski, just prior. I was living in Waukesha, Wisconsin. My twin sister and I are in this photo, and if you wanted to take a guess as to which one is me. Blue or pink? What do you think?
Blue.
Okay, I'm hearing blue. Yeah. So actually, it's the dimples that give me away. I have dimples. My twin sister does not. So that's me in the blue there. And we, just love snow. And this is still how I feel when I see snow in the morning. I look out the window, I see this type of snow, I feel joy. It makes me feel wonderful. And this really is underpinning a lot of my interest in my research. It's also my love of outdoor sports. I learned how to ski at Saskadina 6 in South Pomfret, Vermont. This was back in 1988. It was one of those core memories that one has when they are growing up in New England. And it was just one of those places that really hold a special place in my heart. And I haven't gone skiing there recently. They're still open. However, the last time I was there was actually for the start of the Covered Bridges Half Marathon. So they find other uses for these wonderful resorts out of season as well. I continue my tour de ski world of Liz. This is my very first ski club. This was my elementary school years. So this is at McIntyre. Some people don't know that Manchester, New Hampshire, or Manchegas has a ski resort in it, but it sure does. It's very small, but when you're a little kid, it just seems enormous. And we had such fun memories there as well. I switched over to snowboarding in the early 90s. I was one of the 2 snowboarders at the ski club, and I was in middle school. It was myself and my friend Gretchen. And this is like also just one of those places where I've been back skiing. I don't know if you guys have been here recently. Their cookies are as big as your face. My son loves them. And it's also a place where one of my friends got married. So again, like many uses for these ski resorts beyond the winter season. Today, I've actually come full circle. My son is now taking snowboarding lessons at Gunstock. This was also my high school ski club. I can tell you that the lodge still smells exactly the same. It's a combination of Hubba Bubba and French fries. And it is just delightful. He loves their hot dogs because they grill them. And there's nothing better than a grilled hot dog in the middle of winter. So all of those resorts, they're all still open. But 600 other ski areas across the United States have closed. A lot of them during the boom bust cycle of the 1970s, and not always because of snow. Sometimes it was management operations. Sometimes it was the investment in snowmaking that made them less resilient to those low snow years as well. This one in particular is Maple Valley in southern Vermont. And this photo was actually taken pretty close to the day that I was there. It was in one of my first and only TGR, Teton Gravity research films that I was in. And I met a filmmaker out there from an organization called Protect Our Winters. And we could kind of peer through the windows and we could see on the whiteboard that they had closed mid-season. The whiteboard said like Happy New Year 2000 or 2001. All of the trophies were still on shelves. All of the gear was still in the rental lockers. It was like that place had just shut down in a heartbeat. They just didn't come back from Christmas. It was recently sold, I want to say in like 2017 or 2018, after being on the market for over a decade. And it was at the time being reimagined as a brewery, not necessarily as a ski resort. And this is a part of the reason that we're here. You might see headlines like this: winter easing its grip on the Northeast. And maybe that seems like that could have been something that was published last year when we had our record warm winter in New Hampshire. But if you look closely at the date on this one, this was 2008. And this was actually my master's thesis that I had published in my first peer-reviewed paper. So 15, 16 now years ago, this was what was published. And I went back through some of the climate records for New Hampshire. And since December of 2008, when my paper was published, northern New Hampshire has had one winter that was cooler than the 20th century average. And any trivia, anyone know which winter that was between 2008 and now? Which one would have been colder than the 1900 to 2000 mean? You could put this in the chat too if you're online. Not 2010. Very close, 2015. So 2015 was the snowpocalypse year, Snowmageddon, like we got hammered. I was living in Colorado, of course. But this was the one year that we've had since 2008, since I started work on this research. And part of me starts to wonder whether or not we are going to have another winter that's colder than the 20th century average. Sometimes I can get this sort of feeling that maybe that was the last one. Because we look at what happened last year. You know, we had headlines like this: winter's over. It was the warmest on record. Here's what we missed out on. Winter was warmest for New Hampshire. It was also the warmest for Vermont and New York. Maine had its second warmest winter. If you look at the map up there, you can see this pattern up in our northern, our friends in the Midwest. They also had their record winters as well. And you might, whoops, that was not where I wanted to go. Well, you might be wondering, like, how does this relate to warming winters? You know, sometimes it's just a one-off. Sometimes we just have one warm winter. So I want to start with some basic definitions. What's the difference between climate and weather? And sometimes I do this in the context of what maybe Mark Twain said: climate is what we expect and weather is what we get. We can expect to have cold winters in New Hampshire. We can expect to have snow in New Hampshire in winter. But sometimes we get these weather events that are going to be specific to a place and time, like the December 2023 floods that we had in the White Mountains. So for true definitions that I have my students, they did this on their first exam a couple weeks ago. Weather is the actual state of the atmosphere at a particular time and location, whereas climate is going to be that statistical description of weather over time, 30 years or longer usually. And when we talk about climate change, we're talking about any systemic change in the long-term statistics of weather. So that's going to be sustained over decades or longer. This is an AMS definition. We can look at how this has changed over time. So right now what we're showing is a map of how Earth's temperatures changed from 1880 to 2023. Anywhere you're seeing blue, cooler than average. Anywhere you're seeing reds and orange, that's going to be warmer than average. And this is, I believe, relative to the 1950 to 1980 baseline. So we can see all of these areas of blue in the early part of the 1900s. When we get into the 1930s, you're going to see the US light up in red. It's associated with the Dust Bowl. There it goes. In the 1960s, the eastern US lights up in a little bit of blue there. That's leading up to the Clean Air Act, when we started scrubbing out sulfate aerosols that were blocking the sun. And then a very distinct pattern starts to emerge as we get towards the end of the time series here in the 2000s and into the 2020s. It's hot. A lot of it's up north in the Arctic. We can actually tell whether this was an El Nino or a La Nina year. This was definitely an El Nino year, that very distinct pattern that you see over the equatorial Pacific is associated with warming of El Nino. But El Ninos today don't explain all of the warming trend. Yes, our El Ninos are going to be associated with warmer than average temperatures. But when we look at La Ninas, the La Ninas of today are warmer than our El Ninos of the past. It's a very distinct warming trend, and this is what climate change is. When we think about what this means and who's causing the issue, it's unequivocal that humans are the underlying cause of this warming that we see on in the atmosphere, in oceans and on land. This one is from the 2021 Intergovernmental Panel Climate Change Report. And the way they can come up with statements like this is through fingerprinting with climate models. Climate models are a wonderful tool that we're able to use to understand who is responsible for what, because you can hold lots of things constant and then run a climate model and isolate each of those different effects. And I'm going to walk you through what they did in those climate models, and first what a climate model actually is. Climate models are actually pretty old. The earliest ones were radiative transfer models that were developed in the 1890s, just showing energy coming into an atmospheric layer and out. We added an aquaplanet in the 1960s, so then you start seeing how the hydrologic cycle and nonlinear fluid dynamics impact climate. In the 1970s, Carl Sagan was actually one of the people who had published on the impact of albedo. So how does the land surface and sea ice affect climate? In the 1990s, atmospheric chemistry really starts to get involved. And then in the 2000s and 2010s, we see aerosols, vegetation, and carbon cycle actually showing up in our system models. When we're talking about how they're made, it's essentially taking those Earth system processes that are on that diagram below. So the flux of water to and from the atmosphere, going into the ocean, getting locked up in sea ice. How is energy and momentum and carbon being moved around? We can represent that through equations, and we can put that into a gridded box model, and we can say how energy is moving in and out of the Earth system. If you want to see what a climate model looks like on the inside, you can actually go to the GitHub page. A lot of the climate models now have open source code. This one in particular is for the Community Earth System model. And I'll show you what it looks like. It's that. That's it. These are what climate models are. We take all of those physical equations, we code them up. This one is in particularly in Fortran. It's a very ancient but powerful language. And we can see that we have here, this is just showing a snow aging process. If you look closely at some of the words in here, attempting to read snow aging parameters, it's essentially telling you how much the snow has darkened as it gets older. That's what this part of the model does. And this particular module, it's about 1,400 lines of code. And then there are thousands, millions of other lines of codes that are representing all of those other processes in these Earth system models. Getting back to that fingerprinting, now we can take those climate models and we can say, what happens if we just have these various natural and human-caused components? And we can see what the response is. This is what we know from observations. So taking that movie map, turning it into a time series graph, going back to the 1880s and into present day, well, this one's about 10 years old now. This is what our thermometers tell us has happened. And we can see a very distinct warming trend from about 1980, 1970 onward. Now let's play around with the climate models. This is what happens when you tell a climate model to only change the amount of energy coming from the sun based on changes in Earth's orbit. And we know that changes in Earth's orbit can bring us in and out of an ice age. This is what we see in ice cores. But for the last 125 years or so, we've not seen much of an impact of this. This operates on a much larger timescale, longer timescale than what we are seeing here. So it doesn't explain that warming. This is not a good fingerprint match. We can look at changes in the sun. The solar cycles are responsible for changing the output of the sun on the order of maybe 3 or 5% per year. It's not going to be a lot. You can see that interannual variability there, those little tiny wiggles. But it is not something that's explaining that that warming trend that we see from 1970, 1980 onwards. What about volcanoes? Volcanoes emit a lot of carbon dioxide, but they are not responsible for the warming that we see, because the more powerful effect that we see from them is actually from the result of sulfate emissions. That is going to cause aerosols, tiny little particles in the atmosphere, to block the sun and actually result in cooling. So Mount Pinatubo is right here in 1991. We see almost a degree or two of cooling associated with these volcanic eruptions. And when you look at the volcanoes compared to human activity, we're emitting about 100 times more per year than volcanoes are. Okay. Not a good fingerprint here. When we average all of those natural factors together, and these are 3 of the largest natural factors that we know interact with climate, again, we do not have a good fingerprint match here. So let's look at some unnatural or human-caused factors. Deforestation. When we cut down forests, we're changing how reflective the surface of the earth is. You can take down a big forest, replace it with a field, either in the tropics or up in the north, and you will see that they are much lighter. And this actually has a slight cooling effect, especially in the northern hemisphere where we've taken down a lot of trees. What about ozone pollution? People have probably heard of ozone. It's a very good up high, bad nearby type of situation. It's good up high because it blocks UV light. When it's down low at our level, then that's when we see damage to our lungs. It's actually a really strong oxidant. It's also a greenhouse gas. So it can trap heat, but it only explains a little bit of the warming that we see here. What about aerosol pollution? So when we have volcanic eruptions, we are creating aerosols through volcanic sulfate aerosols, but it also turns out when we burn coal, we're also producing sulfate aerosols. And this has actually led to a pretty strong cooling over the past few years. So not explaining the warming, but maybe saving us from a bit of that warming. When we look at greenhouse gases, now we start seeing a culprit. This is where fingerprinting starts to match up. And if anything, it overestimates it. So why don't we add those effects? Oops, sorry. Sorry. I'll back up for just a second. When we look at greenhouse gases, we can see that they are part of the match here, and that we've also known this for quite some time. This is a graph of the carbon dioxide concentration in blue. That's observed, so what we have measured. And then in red, this is our observed temperature change. And if you look at the source of this publication, this is from Exxon in 1982. They had done a very robust scientific review of the literature back in the 1980s and determined that we would probably see a temperature increase associated with an increase of carbon dioxide. So they knew that this was an underlying cause without all of this fingerprinting technique at the time. When we combine all of those factors together, so land use, ozone, aerosols, and greenhouse gases, now we're actually lining up pretty well. Combine that again with natural factors, now you're even wiggle matching. So you're getting those dips in 1991 that are associated with a volcanic eruption. And so the real question becomes, what are we going to do about it? I like to map out what carbon dioxide has done in my own life. When I started skiing at Saskatchewan 6, we were at 351 parts per million. And if you've ever heard of 350.org, that's what they're talking about. They're talking about getting carbon dioxide back to a level that I haven't seen since 1988. When I went to Pat's Peak, it had already increased 10 parts per million from when I learned to ski to when I learned to snowboard. When I started graduate school in 2005, I had to memorize 380 parts per million as part of my exams. And today I actually need to change the slide because it's not even 420 anymore. Now it is 425 parts per million. It just keeps going up. When it comes to the impacts on climate, the stuff that I am really interested in is the impacts on winter. We know that the carbon dioxide is increasing our temperatures, but it's not evenly distributed throughout the year, nor is it evenly distributed around Earth. When we look at which is the fastest warming season in our neck of the woods, it's very clear east of the Mississippi that winter is by far the fastest warming season. And when you look at New England in particular, we are a winter warming hotspot in the United States. We have increased our temperatures since 1970 by over 5 degrees. This means the place where my parents grew up just a generation ago in northern New Jersey, they have seen their temperatures increase from below freezing when they were growing up to above freezing today. That's a huge shift, especially when you think about what matters in winter the most for these activities, which is snow. When we think about confronting our changing winters, it's multiple aspects of our life. This is a really important part of why we study what we do. It's because it impacts us, the way we interact in New Hampshire. And some of this was published in a recent report that we had done. This was actually back in 2019, but we were looking at the impacts on ticks. That's within the vial that she's holding there. We were looking at the impacts on skiing, and the impacts on forestry and wildlife, maple syrup, and also indigenous populations. Some of the key findings from this were that we're losing the cold. So those days below freezing and our frequent or extreme cold events, they're not only becoming less frequent, they're also becoming less cold. We've seen those temperatures increase. We're also losing snow. There's simply fewer days with snow cover on the ground, on the order of about 2 to 3 weeks if you look since about the last 100 years. And our winters are getting shorter. So that sustained cold period when temperatures dip below freezing and stay below freezing, that too is shortening and largely due to an earlier spring. This is a lot of heavy information for y'all to take in. I know sometimes as a researcher, when I am looking at this data, it can make me feel like I'm longing for something that's no longer there. And it wasn't until about 2017 that this word was put on my radar. And the way it's pronounced is solastalgia. It's a combination of the word solace, which is the comfort that you associate with a certain place, and then nostalgia or algia, that's the Greek root for grief or suffering. So what we experience in winter might be characterized as this sort of mourning, this loss that we're feeling when we look at how our winters have changed and how we experience them growing up versus how they are now. The term was originally proposed in the context of mountaintop removal mining. So if you grew up with a giant mountain in your backyard and then it was removed to mine coal, it's fundamentally changed. That place no longer looks the same to you. When you look at the effects of forest fires, that too could make you feel like there's a sense of loss. The place is never the same again. And on that vein, I would like to hear from you all in the audience that think about what your favorite memories are of winter and celebrate those memories. What are the things that you really enjoy about it? And for me, you know, it's that day when it's freshly fallen snow and the sparkle that you get off of the snowpack in the morning time.
Snow days.
Snow days, the
Yeah,
days you get to
like,
stay home.
Huge. There was huge, like, it ended up being a caterpillar that we made because the balls of snow we made were too big to stack up together. So we made like a 20-foot long caterpillar with all the snow from the field next to the house. Like I just.
So much snow, you don't know what to do with it.
Yeah,
You can't even make a snowman.
yeah.
Yeah, that's wonderful. I love that. That's great.
Playing out in the snow as a kid at night. That was the best.
Oh, when it's snowing or even like on a full moon. Oh, yeah, playing it in the snow at night was a treat. And certainly something we can do in New Hampshire when the sun goes down at 4 p.m.
Right.
Easily attainable. Sledding, yes. Yes, for sure.
Walking out in the winter.
Walking.
We weren't predicted snow, and I was a child. We came up with a surprise, but the next day was coming out and drifting right up to your waist in snow.
Yes,
That's,
that fundamental transform in New York, yeah, that fundamental transformation of the landscape where all of a sudden it is up to your waist as a little kid and you're like shuffling along. It changes the soundscape, it changes just the way everything looks because just everything's really bright in your eyes. And that's what I always try and hold on to is when I am feeling that way is I try to hold on to that magic of winters. What am I working towards? And that helps pull me in the direction where I'm willing to do what it takes to save winters and think about the other impacts that this has on other folks as well. If you wanted to watch a nice documentary about winter and generational change in New Hampshire, I highly recommend this one. It just played at the New Hampshire Film Festival. It's called Remember Winter, and this was a documentary by Gabriel Andrus. And pictured here is actually his father, and his father is a farmer who kept really detailed logs of the weather and the snow and could see it over his lifetime as well. And so Gabe has done a wonderful job translating this into a nice little documentary about New Hampshire as he tries to ski from northernmost New Hampshire to southernmost New Hampshire in Walpole. He ran out of snow, but it's still a wonderful journey. So I hope you enjoy it if you can find it online. Oh, there he is. Yep. Oh, that was the trailer. There we go. Okay. There. So the trailer. It's only a minute.
My name is Gabriel Owens. I'm an independent adventure filmmaker and photographer, passion for telling stories about adventure. Sharing wonder of the film and the beauty of the New England landscape.
So there's also a Windows to the Wild episode that goes behind the scenes in the making of this movie. So if you look up New Hampshire PBS, Windows to the Wild, you can find Gabe's episode on that. So getting back a little bit more to the science, what is winter going to look like in the future? What paths do we have to follow? How is it going to change as we move forward in time? This is the bulk of my research. I have poor posture because I spend a lot of time bent over my computer analyzing climate model output, because I don't want it to look like this. I want it to see what it's going to look like in the future. We know that carbon dioxide in the atmosphere is one of those main drivers. This is what we fingerprinted. This is what we said is causing the increase in temperature. And we've seen changes over time in carbon emissions. Dissolution of the Soviet Union led to a 3.1% decline in the 1990s. When we looked at the global financial crisis in 2008, that too had a big impact, about 1.4% decline. That was also the year I graduated from my master's program. Excellent time to enter the job market. And then in the COVID pandemic, everything shut down. We saw a huge change in how we were moving goods and people around. We saw a 5.2% decline in carbon emissions. I didn't update this one yet, but in 2022, we were essentially around 37.5. I think it ended up being a little bit higher than that. And in 2023, smidge higher than that. When I look at a graph like this, I do see that, we've at least stopped accelerating. We do see a little bit of a plateau. And my hope is that we're very near, or we have reached the peak in terms of emissions. And that maybe, just maybe, in 2025, we will have seen ourselves on the decline. We can use these carbon emissions historically and into the future to see how winter will respond. And the two scenarios I'm going to be able to show you today include what would have happened if we didn't act, so a pre-Paris Agreement sort of situation. What would happen with that since 2015 onward? And the other one I'm going to show you is roughly equivalent to what we would have seen if we had kept 2021 policies. So we had already taken action from 2015 to 2021. And we were on a trajectory that we probably were seeing a peak, and we're going to start seeing a decline. So here's what we get. This is the northeastern United States temperature from 1980 to 2005 in black. So those are the observations. This is from thermometers. The gray line is what the climate model simulated. And then the blue line is what happens under those 2021 policies by the end of the century. So when we look at this, we're just looking at one single model. And we can see that by the end of the century, the likelihood of having a northeastern US average winter temperature, and to give you a sense, this is like Pennsylvania to Maine. So there is a gradient here. You're averaging quite a few regions together, but the likelihood of having a below freezing winter becomes exceptionally rare compared to what we saw in the past. So in the past, most winters across this region were below freezing. And by 2100, it becomes exceedingly unlikely. When we throw in an additional 28 models, so looking at how we model climate at all different approaches around the world, we can see that by the end of the century, most models agree that those below freezing temperatures are going to be unlikely if we stay where we're at. So we cannot stay with 2021 policies. We need to do more if we can stay cold. The good news is, if we hadn't done anything at all, we'd probably be closer to a 4 degrees centigrade increase. That means that winters below freezing would have been out of the question pretty much. So we've done something. We have gotten ourselves from the 4 degree, and we've halved the warming that we could have expected to see if the Paris Agreement didn't happen. That's great news to me. but we need to do more. If you are increasing temperatures above that freezing point, you're gonna have an impact on snow. And historically, is there a way to
You have to click it off on your.
Oh, okay.
Just on
I-
oversee,
okay, it's not showing up.
yeah.
Okay, great. Sorry, there was something on the map there. So historically, this is the area that would have had at least 20 days of snow on the ground. So think of what your winters are like, how many days are snow covered. This was the bare minimum in terms of like, if you had a snowy winter. You can see that it extends all the way down to New Jersey. So when my parents were growing up in the 1960s and 70s, and we were there for a short bit in the 80s, we would have had snow there for at least 20 days. You could expect to see it. Climate is what you expect, weather is what you get. When we look into the future, there we go. If we had kept those 2021 policies, this is what we're looking at. Most of Connecticut becomes snow-free. Rhode Island, essentially snow-free. Northern New Jersey as well. These lines that you see extending into the Poconos and into the Appalachians there, that has to do with elevation. Those are higher elevation regions. The higher up you are, usually the more likely you're going to get some snow. But this is creeping dangerously close to coastal New Hampshire, where I work. And I have to say, December 2023 really caught me off guard, because that was my first year. I've been making measurements at my field site since I was a PhD student in 2011, 2012. It was my first December without any measurable snowfall. And I felt like it happened too soon to me. It was an El Nino year, so we'll give it some slack. This year, I'm hoping for better. Without climate action, by the end of the century, this is where we would see snow-free regions. Everything in the red north has snow. Anything that is south of that, we wouldn't have any. So where I am, by the end of the century, if I were still a professor at 100 years old, I would not have any snow to measure at my field site. Now, in terms of the impacts on our communities, this is the other part of my research. I look at the data, I see how things are changing, and then I see how humans are experiencing those changes. And one of the lenses I look at this through is through outdoor recreation. Something that makes me feel good, that makes me feel happy to be around in the outdoors in wintertime. I will consider sledding to be outdoor recreation as well. And one thing that we've seen is this cultural shift in the way the ski industry has approached this. For a while there at the beginning of my career, it felt like there were a number of folks in the industry that were burying their heads in the proverbial snow, that they didn't want to think about this, that it wasn't real. But it's become really apparent to them that they need to love climate activism, that they need to step up and say that something needs to be done. And not just for their bottom line, but I think a lot of folks are also realizing that there are impacts well beyond ski resorts that we need to be worrying about. Flooding, for example, is an example. And this is why I've engaged a lot with a great nonprofit called Protect Our Winters. They're one of the great organizations out there that are doing their part to go to DC, to go and advocate strongly for climate action, and even develop climate bills with senators and representatives to vote on. So if you haven't heard of the Connecting Our Communities Act, I believe it's called, this is a grid resiliency bill. They want to say, if you are going to build infrastructure for new grids that are more resilient to changes in climate, you also need to give back to those communities where this grid is being built. So not just having those pass-throughs of power going right past us and we don't get to tap into it, but reinvesting in the communities that are hosting that infrastructure as well. I myself have also traveled with the American Alpine Club with the Climate Task Force. This is a event that we did in 2019 pre-COVID, and we got to go see Chris Pappas and chat with him. So some of the folks that you might recognize in here, Micah Berthart is there, very famous climber from New Hampshire, and then Grant Zimmerman is also another famous mountaineer, and they're able to tell their experience of what they've seen, not just in New Hampshire, but globally and in other communities around the world where snowmelt might be a really important part of drinking water sourcing. And it's important that we do this for exactly the reason that we had talked about earlier. Oil companies have known about the impact of carbon dioxide on the atmosphere and essentially kept this hidden until Jeffrey Suprin, published this in 2023, where he obtained all of the internal documents and was able to publish what they knew about climate change. And we need to be doing an equal and opposite effort to advocate for climate action, not climate inaction. And it's not just skiing and riding. We also have other sports here in New Hampshire that are impacted in small communities. The ice climbing community in particular has noticed some big changes. This was a study I had done with some folks. Jimmy Voris was a guide up in northern New Hampshire. Graham McDowell is also a professor at University of British Columbia now. Taylor was with the American Alpine Club. And we worked on a study to see how one of our famous climbing routes was changing in New Hampshire. And luckily we have amazing folks like Al Hospers here in New Hampshire who take photographs of some famous climbing routes on about a weekly basis. And we're able to tie the photographs that he takes with the climate data that we have and get a sense of how that is changing as well. He's also a very famous musician. You should check out his SoundCloud. He has a great 6 minutes, like a jazzy blues Little Wing cover. It's really fantastic. So the place that we were looking at that he had the most photographs of, it was a good 20-year record, it was of standard routes. So this is right here in New Hampshire near Frankenstein Cliff. And we're about 14 kilometers away from the Pink and Notch weather station from as the crow flies. And these are the types of photos that he's able to capture. So for example, in December of 2011, things weren't looking good. It was a pretty marginal situation. In February of 2016, also not a great situation, but you could climb it for sure. This was one winter that was our second warmest winter. So 2024 exceeded 2016. And then in 2010, that was one of the exceptional years. So I'm not surprised. Was it you, Joe, who had said 2010 as being the coldest year? So that might have been your memory of ice climbing that year. So in terms of our findings of this study, we historically found that the season lasts about 100 days based on Al's record. And by the end of the century, if we had not signed out of the Paris Agreement, the season would have shortened to about 30 days. And under our current climate policies, we'll have preserved about a 65-day climbing season. So still substantially short of a 100-day historical climbing record, but we're making progress. There we go. Another great film that we actually documented the process of doing the research. So if you wanted to check out another film, we're not going to play it here. It's about 14 minutes long, but it's a great documentary of what we did in our study and hearing from the climbers themselves and what impacts it has on their livelihoods. So I'd like to conclude with a what you can do. You don't want to leave this type of talk feeling like there's nothing to be done. There's plenty to be done. We already did the Paris Agreement. We were out for a hot minute and then we got back in. But this is something that we need to consider when I give you your first action item, vote. Very important. This is how we can get things done. When I vote locally, I'm able to vote for a middle school that has solar panels, that is LEED certified, that has an investment in the future to reduce the energy usage of that building and contribute to a model of a way to produce energy and educate our children that doesn't cost as much money and doesn't cost their future. When I vote, I'm also voting for community power. That's been a huge thing in Durham, New Hampshire. We now have community power. We can say we don't want to have the energy coming from fossil fuels and natural gas. We want our energy coming 100% from solar. Vote for community power in your communities. If you're not sure if your community has it yet, time to start doing some research and then start advocating for it in your town. The most important thing that you can do about climate change, if you haven't seen Katherine Hayhoe's TED Talk, highly recommend it, but just talking about it with folks who might not be like you. Find that shared value. What do you connect on? And to me, this usually ends up being something like skiing or snowboarding. Sometimes it could be the magic of winter, what your experience was like growing up. And then also commit to learning about climate justice and equitable solutions. When we think about my experience in the outdoors, it is very different from the experience of someone like Marty Fuller, who is the author of this article. And if she hasn't given a talk yet for y'all, she is a top-notch speaker and makes some really great points about what it's like to experience the outdoors as a Black woman. Very different than me going out into the outdoors. So highly recommend her article, and also think about the other ways that climate is impacting us. Impacts on skiing in New Hampshire and snow in New Hampshire, that is one facet that we see, one symptom of a much bigger problem that is unequally impacting communities. So climate justice is a huge part of also why I do what I do. And with that, I will conclude and I can take any questions. So thank you so much.
Yeah, really cold snow, when you
Oh,
asked,
that's
yeah,
great. Oh.
yeah, that squeak, I just feel like the.
Thank
like
you
a
for
certain
sharing.
Noise your
Marsha.
cold makes, yeah,
Marsha and Quentin.
and Quentin, yeah,
Yeah.
yeah. Are there questions in person, Amy? Yeah.
So, was showed a map that suggested that eastern Mississippi was warming faster as warming more than western Mississippi. Why? What is that? How do we have that like mid-continental?
I think it has a lot to do with water availability. So I believe it was, I know her like social media handle, Climate Chirper. I don't remember her real name. But she did a great study looking at the contrast between the East and the West. And so if you look at the Western US, I'm not sure if there's a way to show just the slide deck. So way up at the beginning.
Want the one with the dots?
Yes, the dot one. Yeah, I know exactly which one you're talking about. That's what I was like,
Or
there
did
you
you
go.
want this one?
No, not that one, the next one up. There you
You
go.
wanted this one?
Yeah.
Or did you mean this one, Amy?
It's both. I think
Yeah.
Well, this way.
Yeah.
both say this.
So go to the dot one first though, because that's what I wanted to, yeah. So this one, it's much more summer and fall in the Western US.
That's because they last, the water's not out.
Mhm.
Nothing, right?
And so I think there's like a heat capacity thing going on there. Not my area of expertise,
The
but
next
it
one
is.
is the one.
Yeah, and then there's the Northeast. Why are we such a hot spot? And so with this one, I think there's a lot of a combination of snow loss. So we're at what they call the edge of the snow cliff. I'm not sure if you saw that study by Alex Gottlieb and Justin Mankin. They had published one looking at the temperature threshold beyond which like snow loss really starts to accelerate. And that's right around, oh, I'm gonna blank on the number right now, of course. I want to say it was -18 or -8. So that's like right where you're at the like daytime temperatures above freezing, nighttime temperatures below freezing. And then once you get above that average, you're seeing much more snow loss. So we see this acceleration because we're at lower elevation, because we are losing the snow because of the snow cliff. We're also adjacent to the Gulf of Maine, which is one of the fastest warming bodies on Earth of water. So we're looking at a lot of different factors that are coming together here. Not sure how much of a role the jet stream is playing in this. I haven't seen any definitive studies that have said that this is what is behind it. But yeah, we're vulnerable. Maybe I'll write a paper on that, try to figure it out and get a real good answer.
I'm gonna stop the share and go back to the,
Oh, third act. Yes. Okay. Marsha, thank you so much for bringing up third act. So I actually got to meet Bill McKibben at the recent Protect Our Winters Summit, and he was there and he told us about third act. And essentially, you sometimes will hear this argument, like, you know, to a young person, just be like, good luck, you know, like it's up to you to change this. And it's not up to them to change it. That's Bill's thesis, is that it is not on them to deal with the problems that we created. It is also on us as, and then he's talking about us as in his generation. And so his organization is bringing together folks in essentially what you would call the boomer generation together to say, we're acting on climate. And so one of the great examples he gave, they were blocking banks in DC, I think it was DC or New York, that were invested in fossil fuels. And they went to every thrift store in the area and bought all of the rocking chairs and just sat all the rocking chairs out in the middle of the street in front of the banks. And we're not moving until you divest. So they're a great organization that are also getting really well organized to advocate for climate change and doing so with the community that has a lot of a big voting bloc. Yeah, great.
so then our other question is, it's like,
Yeah.
it's a totally
Fortran.
different question. And so why is the climate model built with Fortran?
Many climate models are built with Fortran. And some of this has to do with the legacy of the code. They are so complicated and intricate that if we were to change it now, it would be a really big effort to do so. It's also that Fortran is a very powerful language. So one of the statistics I've heard is that if we were to rewrite this specific model that I was showing you the code for in something like Python, it would take 6 times as long to run the climate model compared to something as powerful as Fortran.
Which is fascinating, because then that has its own like implication for how much data center, how much energy we're using. Like,
Yes,
it's kind of fascinating to think about like the climate implications of your climate model.
Yeah. So some climate models are being written in new languages, more for ease of use, but the legacy code, a lot of it is all Fortran.
I love the
That's a
like
great question.
span of those two questions. That's great. Thanks, Marsha.
Well, sometimes when I give this talk, I have people guess what language it is, and it's usually someone who was a computer program in the 1970s who's like, nah, they really use Fortran? Like, yes, they do. Great questions. Thank you all. Oh, another one? Yeah, sure.
Yes.
So what I found really powerful about what you presented is how you've connected your own extreme science, right? You are a scientist, you're a scientist hat, with the academic side of it. And so I'm curious, what is your role when you work with people?
Yeah, so working with Protect Our Winters has been one of the most rewarding parts of my career. When you publish a paper in a peer-reviewed journal, I think maybe like 20 people might read it, sometimes a little bit more, and usually that's over a decade or more. Like I look at my most cited paper and I'm like, cool, 120 people use that, like, great. But when I look at who's read the Protect Our Winters reports, like that has had way more eyes on it.
So you write this?
Yeah, so sometimes I write reports. I've done 2 reports with Protect Our Winters now. And some of that is just being able to show up in a senator's office. Don't hand them a peer review paper. They don't want to see that. They don't want to dig through that. You distill the data into something that's meaningful to them, which is how many millions of dollars are on the line in terms of your winter recreation economy. How much of that is going to change in the future based on action that we're taking. Part of it's also just connecting with the people like Joe is in the audience and being able to meet folks that have a really strong role I think you were at Washington Avalanche Center at the time when I first met you. Yeah. And just being able to meet other folks that really care about climate and really care about winter and talk to them. Again, Catherine Hayhoe's thesis is the best thing you can do about climate change is talk about it. And I feel like Protect Our Winters gives me a venue to talk with folks that have much bigger audiences than I do as a scientist. So I can talk to a professional athlete about my work, and they can then talk to their much larger audience about it. Say, I was talking to a scientist with Protect Our Winters, and this is what their research shows. It's another way of disseminating the research that's not, again, the peer-reviewed publication. Yeah.
It's great. Thank you.
Oh, someone, see, Marsha or Clinton, one of them did. Historical analysis and portraits.
Marsha, yeah. And so there's another question in the chat that says, can you discuss the New Hampshire climate assessment that you've worked on?
Yes. So what was nice about the New Hampshire climate assessment is that it went beyond winter. We were looking at all sorts of climate indicators across the United States or across the New Hampshire. And certain things that emerged out of that analysis were also extreme precipitation events. And this is something that we've been seeing an increase in. We were also looking at summer drought indices. So the frequency that we might see summer drought occur in the state as well. And this is a teaching tool that I use in my class. It's not a peer-reviewed publication that goes into a journal. This is one that is meant for public consumption, for people who are not scientists to be able to read through and say, what are the changes that we're seeing? What do we need to plan for? So Ski New Hampshire was actually, they were part of that report. They have a little call out box in there as well. But I think it's been a great way that we're able to look at what's happening in all the seasons, not just in wintertime.
Is there a report similar that will cover like within the US?
Yes, so the National Climate Assessment, that would be a great resource to look at all of the different regions. So the Northeast, I believe that goes West Virginia up to Maine. So that sort of area. And for that one, you get much more broader regional trends. There's also some great chapters in there that are on the climate solutions that are looking at, they also have a great art gallery in there, which was really cool to see them incorporate that to communicate people's experience with climate through art. And one of my favorites, when I would do this with my students, I have them peruse the gallery and take a look at all of the art pieces. And one of the students that I had from Montana had pulled out a forest fire image. And if you look really closely at it, you can see that it's actually a quilt. And the person had stitched together this beautiful quilt of a post-fire landscape. And it was a really stunning and shocking contrast between a quilt that you associate with comfort and, coziness, and this landscape where that's no longer there. So it drew out that nostalgia. And for her, she had a forest fire come very close to her house in Montana. So the National Climate Center is a great place to go if you want to see across the United States where climate is impacting different sectors and different regions.